Hello everyone. So I'm Alexis Paillet. I will talk about management of resources and waste on the lunar surface. So first of all, thank you to the experts. We work together to perform this presentation. This panel is constituted by industrial, academic, university, and institute in order to present this presentation. So previously, you saw a lot of information by Jerry, Dylan about what kind of resources we have on the moon and how we could manage to respect these resources and manage the waste we have on the moon. So what it takes to build a sustainable lunar infrastructure on the moon? So first of all, we need to have a design thinking from onset. We have also to have a life support efficiency to preserve our sustainability, like air, water, energy, and a lot of things we need to be on the moon. And also we need to work on the dust mitigation, because dust mitigation is one of the main problems we could have. It's a good challenge for us to stay on the moon. In order to do that, we need to have a circular system with a terrestrial application. How we do that? Today, with some agencies at ESA, CNES, NASA, JAXA, and others from the ISECG and TWG, we are working on several thematic areas like advanced manufacturing, energy, off-world living, crew health, performances, disruptive technology like artificial intelligence, virtual reality, digital twin, and other things like space resources, so ISRU, from resources to waste and waste to resources, because on the moon, waste will be our resources at the end. And also we are working also on robotics in order to work on that. So come back on the Earth. On the Earth, we have everything, so it's easy. But in fact, we need to have a safe place, healthy air, water, and everything. So now if we go today on the ISS, because it's the main facility we know, on the ISS we have good things, because our life support is very efficient, with 42%, for example, on recovery of air. On the water, it's 90%, but we need to go deeper on this kind of technology in order to be more sustainable when we will go on the moon and forward. But on the ISS, there is one issue. The issue is the waste production. For example, on the waste production, we have 2.5 tons per year for 4 astronauts. What could we do with this waste today on the ISS? Today, it's just going back to Earth on the atmosphere and burn on the atmosphere. So when we go back, when we will go on the moon, it's not possible to do that because our waste will be the main resources we need. So in order to go on the moon, we need to increase, to develop, to improve our main technologies. So deep space, deep exploration, deep human flight exploration will be driven by technology. So technology in order to improve our technology, for example, on the life support, on monitoring, on the crew health, on radiation protection, on fire safety, logistics, and a lot of things we need to stay on the moon permanently. So we need also to reduce our cargo frequency. So today on the ISS, it's each month we have a cargo going to the ISS and come back in order to give some food and other things to our astronaut. But if we go on the moon, we need to reduce that maybe one each 6 months or one each year in order to help the recovery. We need also to have an in-situ production. It was very well presented previously. We need also to create a closed loop. Each loop are very important. A loop for the air, loop on the ISRO, loop everything. So in order to have an in-situ recycling. We have also the dust mitigation. The dust mitigation is, we need to take it into account for the landing and takeoff, and also for the surface transportation. What will be the stage on the moon. So it was presented previously by Jerry about the Artemis program. So it will be a step-by-step approach. So we have an approach with midterm and long-term. So until the midterm, so maybe it will be in 10 years, we will have some human spaceflight exploration with 2 astronauts on the moon. Maybe we'll stay only 15 days on the moon, something like that, or on the South Pole. So we will have some non-organic waste and also some organic waste. About the non-organic waste, like Apollo, it will be piling to recycling. And we need also to register all the items we have on the moon in order to reuse this item later when we will be able to recycle all these items. About the organic waste, it will be from ISRU, like peeling and burying, to the recycling. So peeling and burying, it was we performed when during the Apollo mission. So we will start with this kind of things at the beginning. What kind of things we need to develop in parallel on the Earth? It's to develop recycling technology in order to recycling metallic things, plastic things. We need also to develop our food management and prepare the ISRU regolite for the second step on the moon. So the lunar, to prepare the lunar outpost. The lunar outpost, as presented by Bernard, by the moon village, it's 6 astronauts, 6 months on the moon. How we could do that? We have also some non-organic and organic recycling. So we need to close the loop now with organic and non-organic things in order to be more sustainable. And also we need to treat our waste in order to create some gases and bricks thanks to the ISRU. And in parallel on the Earth, we need to develop the food production in order to have an in-situ food production when we stay on the moon or beyond, and improve our recycling for the life support technology and improve the ISRU regolite production in order to have a lunar international station. So I call it like that because I don't have exactly the final word. But if we would like to stay on the moon for permanent things, we need to be sustainable and to increase our autonomy in order to have, for example, 6 astronauts for permanent lifetime. So full circular resources, and thanks to that, we will have a terrestrial application. So with the exploration, it's a good vector in order to create spin-in, spin-off activity in order to have sustainability on the Earth. We do that in order to have autonomy, because today the moon is not the final target. The final target is Mars, and moon will be our proof of concept in order to prepare everything when we will go on Mars and stay on Mars. So we are preparing the moon to Mars exploration. So I have some example of circular resources management. So I take only the institute or agency things we perform today. For example, at NASA, we have this program. At ESA, we have also this program, it's a Melissa. But behind these 2 initiatives, of course, we have some academic, industrial university are working hard on all the technology we need, because on the ISS, okay, it's like that, but now as we would like to go in deep exploration, we open some window, and some window we need to take it from the Earth and improve this technology from the Earth in order to push and to be more autonomous. So it was my last slide. So the resources and waste management for the lunar surface. So we need to have international agreement. So COSPAR is a good way to go in this direction. We have also a long-term mission, so waste resources. We need to elaborate some new technology in order to have this kind of system. And this system, we need to be well organized, so we need to know everything we bring to the moon. So this system need to be identified, best system architecture, so we need to work together in order to know what kind of thing is behind that. And also we need to elaborate some international and multidisciplinary community, and some synergy needs to be done between space application and Earth application. So thank you.